There are many goals of the .NET framework, and when they were designing it, putting it together, one of the things to keep in mind is that the .NET framework is intended to be an object-oriented programming environment where it is going to provide the facilities to be able to develop methods and properties and objects and classes that will implement abstraction and all of the other object-oriented concepts and principles. We also want to minimize the amount of deployment and versioning conflicts. We want to be able to have code execution in an environment which is going to promote safe execution of the code. There are many goals of the .NET framework. These include object-oriented programming concepts, making an environment where you don't have as much to worry about with regards to versioning, the challenges with the DLLs, mismatching, and creating an environment where the developer can focus on the application, focus on building the solution that they need to be able to deliver a great solution. The code execution environment that runs on different machines, different kinds of frameworks and platforms being consistent across, eliminate some of the problems with performance, and make the developer experience consistent across platforms and across languages. There are many components of the .NET framework, and the two core are going to be the Common Language Runtime, or the CLR. And what the CLR is it is like in a virtual machine, a Java virtual machine or JVM, it is going to be the runtime, the machine that's going to take intermediate language and compile it down into native code. It has a number of different priorities, including managing what the code looks like at execution time. So it does just-in-time compiling of the intermediate language into native code. It's also going to take care of memory management and garbage collection so that when objects are out of use, that they get cleaned up and free up the system resources. It'll handle the thread management and handling the processes working across different cores and remoting into various things, as well as handle any security issues with regards to that code. The other major component of the .NET framework is the class library. And what the class library is it's a collection of reusable types and classes that are tightly integrated with the Common Language Runtime, including base types, including a number of different facilities for going out and interacting with the machine. The base class library is also very object-oriented. There's also a common type system. The type system establishes a framework for cross-language integration. What that means is that if I'm writing my applications in Visual Basic, or I'm writing them in C++, or I'm writing in C#, or whatever the language is, that it will define out how the types get stored in the intermediate languages. The types include classes, structures, enumerations, interfaces, and delegates. There have been many releases of the .NET framework, and understanding how these have come out is helpful for diving into the fundamentals of what .NET is. The first release of .NET came out in 2001 and 2002 with the .NET Framework 1.0 and the first version of the Common Language Runtime. The version 1.0 was not compatible with 1.1. In fact, if you had one of them installed on your machine, you couldn't install the other one. They were not side-by-side deployments. 1.1 came out in 2003, and then in 2005, the .NET 2.0 framework came out, and subsequent releases included the 3.0 and 3.5. These were running on the CLR version 2.0. And the nice thing about the release is that the versions 3 and 3.5 were additive to the 2.0 framework, which means that if I was in Visual Studio, I could go out and I could work with the 2.0 framework, install the 3.0 and the 3.5 framework, and then optionally choose whether I wanted to target those additional frameworks. .NET 4 came out in 2008, and the 4.0, 4.5, and 4.5.1 releases are running in the CLR version 4. The .NET framework is really composed of a number of different things. The Common Language Runtime, which is responsible for the just-in-time compiling and generating native code, memory management, the security and exception handling, and loading of the assemblies and code and the physical execution files as needed. On top of that sits the base class library. That is something we talked about that has things for like strings and for different objects and different access for like network information. The base class library includes a a large number of classes and objects that we can use inside of building our applications. On top of that, we've got the features of the .NET framework, things like the Windows Presentation Foundation based on XAML, or Extended Application Markup Language. It also supports ASP.NET, or web applications. It supports services, language integrated query, the dynamic language runtime, and much, much more. All of these are used to deliver a great solution. Some common terms that you'll run into when you're working in .NET, things like managed code. What is a managed code? That is code that runs inside of the .NET framework. So inside of the CLR, which is like a JVM, like a virtual machine that is running, that is abstracted away from the actual hardware, has a common input, which is the intermediate language. And the managed code is written so that it compiles down into that, and then at runtime it is converted into the native language of the hardware that it's actually sitting on, the platform. Code that you create in Visual Studio for .NET is called managed code. Unmanaged code is code that is built directly on the framework, like C++ can develop unmanaged code for talking directly to the lower level operating system. An assembly is a file that contains some managed code. Sometimes these are called physical executables. Common Language Runtime is the system that will take the managed code and actually execute it and manage all the memory. We also have portable executables, which are loadable files containing the metadata about types and classes. MISL, Microsoft's intermediate language, is the language the .NET code is actually compiled down into, and it is then compiled at runtime into the native code. And then a number of tools are available for working with these assemblies, one of which is the GAC util, or the tool that allows us to actually go out and insert and install assemblies and common code into what's called the global assembly cache. The global assembly cache is used by the .NET framework to contain common libraries and blocks of code that are used across multiple programs. ILDASM is an intermediate language disassembler, which is a tool that we can use for looking at the contents of an assembly. In .NET, we have a lot of different options for how we go through and work with the languages, programming languages, to develop our software. Feature parity exists inside of these programming languages, which means that each language can develop and build the same set of features and functionality as the other languages. For example, C# and VB have a parity so that if I'm building .NET framework, I can use that framework because the base class library is common across the different languages. The different languages that are supported by the .NET framework include C#, VB, C++, F#, JavaScript. The language you choose depends on what kind of language or what type of a developer you are and what you want to do with it. Visual C# is a language that is one of the original .NET languages, and it's built on top of the C++ syntax and semantics, which is nice if you have been building applications in C++. It's an easy move to go into C#. C# has got a number of great features developed by Anders Hellsberg back in '99, and then was extended out through various releases. Some of the characteristics of C# is that it's strongly typed, declarative. It's a procedural language with a number of different types. It supports lambda expressions, generics, optional named parameters, etc. And it's also designed for really code-oriented developers. If you're not a code-oriented developer, there's VisualBasic.NET. Visual Basic is another of the core languages of .NET from the very beginning. It's an object-oriented language that has evolved from the classic BASIC, using syntax where we don't have semicolons at the end of lines, we don't have the curly braces. It's more of a designer-oriented kind of a language. It has a number of different features about it. For instance, working with properties, it will automatically implement those so that the syntax that we actually write when we're writing out our code is going to be simplified. You also have collection initializers, and you have line continuation. So Visual Basic.NET and C# have evolved over a number of years, from the first release with .NET back in 2001, 2002, with C# and VB, where they introduced the concept of managed code. In the version 2, they included generics. In version 3 of C# and VB9 in Visual Studio 2008, they added a number of features, including language integrated query and dynamic language parity and C#4 and VB10. Asynchronous processing, or the ability to handle multiple threads and multiple processes running at the same time, really came into its own with Visual Studio 2012 and the release of C#5 and VB11. Other languages, for instance, like C++, is an object-oriented language that evolved for being a core language of Windows. Some of the features that are new inside of Visual C++ is the ability to restart and autosave documents after it exits. Lambda expressions are now available in C++, and there's a task dialog for handling the message box processing. F# is a functional language, which includes support for functional programming, in addition to the procedural code and object-oriented code. The support for the F# is now fully supported inside of the IDE. It includes pattern matching support, asynchronous constructs, and a number of other features that make it into a very useful language. The considerations for when I'm going through and determining which language do I want to work with really comes back to what kind of developers am I working with? Who do I have on staff, and what does my investment look like? What languages does your development staff already have and use? If you're in an existing situation, you probably are going to use a language that is most familiar to you. Another consideration when you're looking at building new applications is what type of client are we doing? Are we doing server-based? Are we building a bunch of services? Are we building phone development? Are we doing something that needs to run across multiple platforms? Determining what you're building, who's building it, and where they're building it, that drives back into the languages that you go out and choose. Another thing is to think about is performance. Are there limitations? Are there things that we need to be able to get to that in one language is going to take a lot more code to implement than in another? In any case, after we've built out our software, built out our applications, we have to package it and deliver it and deploy it into an environment where we can actually go out and use this. So for deployment and packaging, we end up creating portable executable files. These can be EXEs, or they could be assemblies, they could be DLLs. These files contain metadata that is going to describe what this application, what the code contains. It includes a manifest, it'll have some local assemblies, and it might have some references to the global assemblies. These are then packaged together and then are put into an environment where then the CLR can go out and execute them. These live as what's called intermediate language, IL, and IL is compiled by the CLR into platform-specific code at runtime. This is the executables that come out that then are doing the business of it. One of the characteristics of intermediate languages, it is object-oriented. It uses interfaces to go out and define the characteristics of the code that's running. We've got strong data typing and exception handling as characteristics of how this language is written. And then it's got a number of different attributes such that we can really dive into what this intermediate language looks like. If you're interested to see what it looks like inside of the code, you can use a tool called ILDASM, which is installed with the .NET Framework. And if you go into Visual Studio and you take a look at the tools, so you can run ILDASM just from the Visual Studio command line. So to take a look at the ILDASM tool and to kind of get into what this is, let's take a look at a typical application, and then we'll open it up with the ILDASM tool. So I'm going to go to the desktop, and I've got Visual Studio open. You'll see in my solution provider I've got a C++, I've got C#, JavaScript, and I've got a VB, all running a Windows 8 demo. And they're all doing pretty much the same thing. So if I were to go ahead and run this in the local machine, Let's go ahead and run this. So rebuild and then run. It'll deploy the package out to the environment. If I click the button, it says click me, takes me out and shows me a hello world message. Coming back over here, if I go to the VB or the C++, set this as my startup project, and run this one, and then say run it, it'll again go out, build the project, bring it up, click the hello world. You can see the click me button. Same kind of an idea. We can do the same thing from the JavaScript or the VB. So if we take that and say start a new instance, again, HTML, JavaScript, all of these applications have similar functionality. And if we look at the code of what's going on inside of C#, we've got a main page where we got a button. If I open up that button, double click on it, it'll open up the handler, and I can see here's the handler where I'm going to go out and I'm going to do this show dialog asynchronous. If I go to my Visual Basic and I take a look at the code, I've got my go out and dim RC is equal to a dialog, which we then show asynchronous. The idea is that this gets created into a project, and if I go up into Visual Studio, I can click on Show All Files, and this is going to show the bin directory, and it's got a debug, and inside of here I've got a number of other files. And if I go out here and I take a look and I say, here's my Windows 7 demo vb.exe, that is the actual portable executable file that will run this application. And what I want to do is I want to take a look at that from the LDASM tool. So I'm going to come down into the start page, go down to where we've got this installed, and if I come over, you'll see I've got Visual Studio Tools. If you run the command prompt, it opens it up, and I can type in LDASM. And this then opens up the tool that lets me peek inside of these assemblies. So I can take this, go to the file, say open, and then I'm going to come back to my PC. And I've got my Visual Basic, bin, debug, and there's my Windows 8 demo VB executable. If I take a look at this, you'll see that the assembly contains a manifest that has information about this runtime, and then it has a series of objects that are contained inside of this. The main page has the class for how I'm doing things. There's a button click, which is going to handle the actual showing of information. There's even information about what that button click event is going to look like. This looks very similar if I were to go out and say, let's take a look at the code from the C# one. Same kind of deal. Go out to the AppX directory, and there's the executable. Again, almost identical. There's the main page, there's the button. You'll notice that it's got the assembly in the intermediate language that is then compiled and turned into actual runnable executable. So LDASM allows us to go out and see what the code is going to look like, and regardless of the language that we're using, we'll find that we can get into these assemblies and the portable executables and be able to understand more about how that application is written.